welcome to Terms of Living. I want to introduce something I've always been interested in, even ever since I was a child, getting electrocuted in the plug socket. Always found the, what's the word, the enigmatic, the elusive, what is it, the thing about electricity, electronics that's sort of in its own domain over there, and it's almost the people who understand electronics are almost some sort of cult or something. Well, that's the point of these videos. I want to get rid of that. You know, if you're an average person, especially, you know, the thing about electronics is a little bit of knowledge and really a little tiny bit of money. I mean, really small amounts of money. What are we looking here? We're not even looking at $10. Maybe breaking 10. Maybe breaking, yeah, we might be breaking $15 or $20 worth of electronics on this board. Okay, it's a cheap thing to do, and it's an amazing thing that you can do. You can do amazing things with electronics. And to understand them, then all of a sudden now you can fix a bunch of things. And it's really not as difficult. I remember when I was a child, and I think it was first grade, or maybe it was third grade, but I had, and I guess the rest of my classmates had just learned how to print. There was a P and an O and an M, and et cetera, et cetera. And I think it was third grade, sitting there looking at the classroom around the top. Remember, and at least in the classrooms that I attended back in the 70s, around the top, above the chalkboard, because there were chalkboards then, it would have the alphabet, and it had it in cursive, in script, and I had never. I knew what it was. I knew that this was this alien phantom script stuff, and I remember sitting there. I don't know, I don't think I had my hands folded, but if you could imagine just a kid sitting there with his hands folded, thinking to himself, not sharing with anybody, just this idea that if these people think that they're going to teach me how to write this way, they're out of their mind. Well, of course I learned. Electronics is the same way. It's just a step-by-step thing. And you internalize some basic things. Then you realize that, yeah, you have to do some calculations, but you realize what you're doing is you're saying, oh, I need a big resistor here, and I need something that's, you know, maybe about 1/10 the size here, and I need something that's like bigger than both of these together here. That's the kind of thinking that you can start employing, rather than, well, I need a 15,000 ohm resistor here, and I think I'll need a 680. You can divvy it down to a point where it's understandable, and you can do a lot of cool stuff with it. And I've done some cool things around my house. In my kitchen, I have a nice lamp that I've installed under the cabinet. Basically threw it together. I needed lighting over there. Kitchen was nice granite countertop and everything, and I wanted something with a switch that that wouldn't make any noise. If you know, that's a momentary switch that I'm using there. Something that, basically the switch is how you communicate to the microprocessor. And the microprocessor is really what does the turning on and the turning off. The button there has really doesn't interrupt the electricity. It's just a communication device. It's the most simple type of communication device that goes back to that microprocessor, and the microprocessor says, okay, on, off, or dim. And what are we using there? We're using pulse width modulation. It's just basically saying on, off, on, off, on, off, you know, really fast. And there's some imperfections because that's something that I designed. I mean, right from scratch. It's pretty cool how it works. I just hung it off of the 12 volts that powers the light. And there's all kinds of things, wireless things that you can do, interesting things in terms of remote control. And what it really is it's just having a a base set of understanding, and it doesn't require. I mean, this is physics. This is like throwing balls. This is like shooting arrows. All the things that we do in our normal lives that are predictable and understandable. This is it's awesome stuff once you get to understand it, because then all of a sudden you increase your opportunities. I mean, even in the most sort of, hey, I'll fix that for $50 situations, and people would be more than happy if somebody could come into their life and fix some of this stuff. And I've done a lot of circuit board repairs, and I have to tell you, 85-90% of those problems are power supply problems. And I would say of those, especially in an older board, like something from a treadmill or something, 50% of those are just little cracks in the solder. It's amazing. If you can just figure out how to determine, if you can figure out how to look at something and just determine, is it running? Is it not running? Anyway, getting off a little bit there. So it's just a basically general philosophical approach to having the ability to handily deal with these electronic issues. And once you basically get an intuitive sense, then it's like anything. It's like how you go out to your car, you can change a tire, or you can change a washer in your sink, or all of these different things that you can do. Electronics becomes like that. Oh, let me just test this and check this. The thing is, you have to sort of understand, because you're dealing with something that is not readily visible. It's definitely visible in the physical world. You see it with light bulbs and motors, and I mean, it's definitely visible. It's just that the nature of it, you have to sort of understand a little bit of it. And that's the first thing that I'd like to talk about. Now, what is electricity anyway? I mean, whether we're talking about electronics or flat out electricity, what the hell is it? Okay, so we know, and I'm going to blow right through this fundamental stuff because I just want to make one or two simple points. We know that all matter is made up of molecules. Those molecules are made up of atoms, and atoms have nuclei and protons, neutrons, electrons, right? But the main thing about electricity is we're not concerned with all of that. That's a black box to us. But the main thing is that all electrons in every substance, plastic, wood, oxygen, any gas, liquids, the outer part of the atoms contain electrons. And in some substances, like metal, those electrons just move freely. There actually is friction, but they pretty much move freely. Just like you pour water out of a glass, that's freely, but there's friction in there. There's definitely friction in there. So inside of a substance, the electrons may or may not be able to move at all, generally speaking. I mean, if you apply enough potential, you can do a lot of crazy stuff, but under most circumstances, metals will allow electrons to move across the substance. And that's essentially what electricity is. Electricity is the movement of electrons through substances, powered by potential. Okay, that's a little fuzzy right there. Voltage. In order to move something, you have to have a force, right? You want something to roll downhill, you have to bring it to the top of the hill. The same thing with potential. But don't get too caught up and worried about what potential means at this point. Just understand that electricity is the movement of electrons through stuff, or not, like the exterior of a wire, the plastic. Another analogy that I'd like to draw is people often talk about electricity as water flowing through pipes. And that does work to a certain degree, but when we think of water flowing through pipes, if we disconnect the pipes, we tend to imagine this, like, So what we want to imagine with wires being pipes is that the atoms don't move, the electrons do. So the pipes are essentially primed all of the time. In a water pipe, disconnect it, and then the water comes out, or whatever kind of liquid, right? Then you have the air coming in, you have these weird pressure problems when you try to, if you just close this up. Wires are not like that. Wires are sort of pre-primed, you disconnect them, and then all of the substance that travels is right there. So you move one thing at this end, and one thing pops out immediately, or at least at the speed of light. At the other, well, not exactly, a little less, right? Because it's not through a vacuum. Blah, 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 blah. You know, there's always people out there who are worried about like these small things. As I go on, I'm going to become less concerned with hitting all those tiny points. But to think about electricity effectively, what you want to do is when you see a wire, you just think of it as already full of the substance that's supposedly traveling in it as an analogy to a pipe.